Hello everyone, my name is Ren Kaido. Today, I'm excited to share with you an insightful project on predicting medical insurance costs using machine learning. By analyzing key attributes such as age, BMI, smoking habits, and region, we can build an accurate regression model to help insurance company and individuals make informed decisions. At the beginning of the project, we first gather and proceed the data set first, and the first step is to import all of the package we needed, such as NumPy, Pandas, Seaborn, Matplotlib, such as that. And then we need to loading all of the data set. We call the data set just DF. And this is the info of the data. The data such as sex, smoker, region are object type, and age, BMI are numerical type. After that, we need to import the data set, which is already encode everything. Encode the sex, encode region, encode smoker, yes or no, to 0 and 1. And this is the train shape and test shape. The reason why we need to do the train and test is we divide them to make sure we can compare the results to prove our learning model does not overfitting. And the next step is checking the missing value in the data set. There are no missing value in the train data set and no missing value in the test data set. That's good. For the duplicate parts, there are only one duplicate data in the train data set. Only one doesn't cannot affect anything, so we don't need to care about it. And the DFN unique sex, we have men and females. Six, which means someone has 0 to 6 children. Smokers, they smoking or not. Regions, there are 4 regions inside the data set. That's all. So this is the first graph we can see in the data processing, which means the majority of people in the data set are less than 20 years old, which means this data or this result only for young people, not for older people. And then we can looking for the heat map. In every heat map, one represents the positive relationship, and negative one means the strong negative relationship, and 0 means there are no correlation between these two factors. So obviously, charges has really strong correlation with smoking, yes. So if a people smoking, the insurance charge will increase. And same as here. And as the higher BMI, the charge will increase. The higher of age, the charge will increase. For others, there are no obviously correlation between them. Even though there are some negative correlation between the region, but the region cannot be an like become a very essential element in the machine learning. So let's begin the next part. At here, we can see some data, outlier data at here. For the BMI, there are 9 outliers greater than the bound. 9 outliers will not affect anything. We can leave that alone. But for the charges, there are 139 outliers greater than the upper bound. Maybe we can use the log transform or use the another use try to use a normal distribution to make the charge data more concentrate, and it will not affect the fitting of the train and the test data set. This is the graph. We can see the BMI and charges. So as the higher of the BMI charges increase, we can see in this graph with the lower BMI, the charges under 10,000. But if the BMI is getting higher, the charge is getting higher at at this part. But not everyone, not everyone. And this may caused by the age, caused by the smoking or not, caused by the living habits. For the there are Yeah, we can see it here. The older values and charges, there are a lot of outliers. Maybe we have to deal with something for the charges. For the charges dispose, it's right screw and charges probability plot at here and at here, and so we have to change the shape of the charges. Maybe use the log. And for the BMI dispose, the BMI does not have any outliers, and BMI is normal distribution. We can use the BMI value directly in the machine learning. And the probability for the BMI plot is nearly linear, or it's just linear, so it doesn't matter for this one. Sex, they are same for the male and female are nearly the same. And a lot of people in the data set are non-smoker. For the regions, whatever the people is from southeast, southwest, northwest, and northeast, they are near the distribution for the region is same. And a lot of people are concentrated in 18 and 19 years old. For the children, a lot of people in this data set doesn't have any children, and only a few of them have 4 or 5 children. The violin plot of OR, it shows that the BMI is at the center, and for the charges is not have strong relationship with the BMI. But if we can see between between the one and negative one, as the increase of the BMI, the charges is getting wider. This is a heat map, children charges, and yeah, as the age increase, charge will increase. Age, age, yeah. Children will not affect anything. Where the BMI increase, the charge will increase, and nothing else. Age and children will not affect anything in the model. Average BMI for the region, so every region have nearly the same BMI. The distribution has nearly the same, and the average charge by the region is the southeast has the highest, but not has the like significant higher than other region. Charged by age, 60 older people has higher charges by age, and older people always has higher BMI if people the age is over than 50. Every limit by children, the children will not change everything, same as the charges. Every charge by sex, sex will not change everything. The BMI by sex is same. Male and female do have same probability for the same BMI, and the average BMI of smoker same. Every charges by smoker, yeah. Like if someone smoke, the insurance for them is much higher than no smoker, than no smoking. This is all of the data set. Train data. We have to divide the data into 80 and 20. 80% for train data and train data set and 20% for test data set. This is the test data set. We have age, sex, BMI, children, smoker, and region. And continue. We use caret to show off the model we used. So for here, the best model at here is gradient boosting regressor, random forest regressor, light gradient boost machine, and extra tree regressor. This four is the best. And the GBR has the highest R square, which is I preferred, and has the lowest MSE, which means it has the lowest mean square error compared to the real data. So this which means GBR model has the highest accuracy. And after we use the five-fold tuning, the R square is coming to 0.835 and the MAP is 0.386. The mean square error is getting higher, but the mean error MAE is getting lower. So that is our final model of the XGB model. And we still can use the tree model to train the data set at the same time. But before we do that, we can see the train score and test score to make sure the graph is not overfitting. After we tuning the model, we like we make the model more fitting than before. And every model is in every point is nearly really close to the linear line. So which means the model is really good at here. Because the accuracy R square is about 0.84. It's really high in the linear regression. And that's the way we can export all the data set and all the final value to an CSV. Feature selection for now, before we use tree, is we use the train data set for tree is age, BMI, smoker, and charges. Test test set for the age, BMI, and smoker. First tree model we use is the regression tree. Same things, scale fit, and we set seed and train data, test data, and the best dips for the tree model is 4. If it's less than 4, the prediction is not very accurate. But if the dips is increased like 6 or 8, maybe the model will will shows the overfitting. And the average MSE is 2169. Actual predict. Sounds good. The final model, export to CSV for the random forest tree model, same way. And the dips is still 4, and here is 212. And it's underfitting, not overfitting. That's good. We export it to the CSV, and that's all. And if let me choose, I will choose the regressor model, which is the XGB regressor. But if let me choose a tree model, uh, I think re this is the regression tree of the decision tree regressor, and this is 2169. I think I will choose the random forest because random forest have the lower MSC, which is 2121, and dips are same. So tree model for me, I will choose random forest, and that's all for tonight. Thank you, everyone. Thank you so much.